Hello, so today we are going to take a look at Kotlin properties and go over how to define them, how to use them, what are the different usages and all of that. So first, let's mention that in Java, the combination of a field and of its accessors, which mean basically get and set of the field, that combination of the field and its accessors is usually referred to as property. So Kotlin kind of takes that concept and allows you to just declare the property right away, and then Kotlin will generate the accesses for you. And so from there, if we just to take a look at the syntax of declaring a property in Kotlin, it's the following, right? It's you declare either var, or it could be val as well, depending on whether the property is mutable or immutable. And then the property name. And then you could provide the property type. This is optional, so the ones between brackets are optional, so property type is optional. And then you could also provide the property initializer, which basically means, let's say you say var or val name by default equal to empty string. So you could have a property initializer, and then you could define your own getter and setters. Custom getter and setter. Otherwise, these are optional, because also if you don't, Kotlin will just generate them for you. So let's take a look at the first example here. So I have a class here of employee that has two properties, name and is manager. Name is a string, and you can see it's declared with val, so it's a read-only property. It's immutable, it can't be modified, so it's a read-only property. And what this would mean is that we can't set a value to it, right? We can't change its value, so it doesn't have any setters functions. So Kotlin will not generate a setter function for vala properties. And so here, this is a read-only property, and Kotlin will just generate a field, the backend field for the property, and the trivial getter, which is just a getter that will return the value that is in the name property, right? With this example, var is manager, Boolean. It's var, so it's mutable, so it can be set, so it's a writable property, and Kotlin will have a field and a getter and setter for it, right? You can get it, you can set the value, and it has a field to store the value in memory, right? Another example that we can take a look at here is I have a class person that has a first name, right? With the initializer to empty string first. You can, of course, define your own get and your own set. Here I'm just using the default behavior. So as what I said here is Kotlin generates a field, and that field can be accessed using this field identifier. So this field identifier represents the backend property. When you reference it under a property here in the getter or setter, that represents the real backend field that stores the value in memory. So the default behavior with Kotlin is get will just return you field, and set will just set the value, right? Set the field, the backend field value with whatever is passed, right? But these are the default what Kotlin generates. So you can see here it's saying it's giving me an error saying that this is a redundant getter and this is a redundant setter, right? Because these are the same that Kotlin generates, so I can just remove these. And Kotlin will generate them for me. Okay, so yeah, pretty much we can initialize it, so constructor without a new in Kotlin, and we can set it. So when we call p.firstname equal to a, what will be called is the setter of this function. So what we had before, this set here would be called. And then when we do p.firstname, right, when we just call the value of the property, it will call the get function, right? And so that's pretty much it. Just to reiterate, a field is only used as part of a property to hold its value in memory. Fields cannot be declared directly, right? But when a property needs a backend field, Kotlin provides it automatically, right? So Kotlin will provide automatically one for you. And as we saw in the previous example in person, you can reference it using the field identifier. The other thing is you can define your own custom accessors for a property that do more than just the default behavior. So if we take a look at this example for how to create your own custom getters, what will happen if you create your own custom getters is a getter will be, or the whatever the body of the get function is, will be called every time you access the property. So that means that this here would be called every time you say person, which is an instance of person2 here, that name. Every time you do that, the get function will be called. And so here, you can see I'm just customizing it a little bit, where every time you do get, we convert the name to an uppercase, right? And so yeah, if we take this here, let's move it down here and just define person2, right? And let's just give it its name something. So John, right? And let's reference that, and let's see if it will be converted to an uppercase. Taking a little bit of time. Yep, so you can see it's converted to uppercase. So every time this accessor here would be called. The other example is this rectangle function. So here you can note here that the name property was mutable. Here I have it immutable, and this one had the backend field. This one has a custom getter but doesn't have a backend field, so it's kind of computed property here. Let's say I have a rectangle that has a height and a width, and I want to know if it's a square. So to know if it's a rectangle. To know if it's a rectangle, I can just check if the height is equal to it's a rectangle, and I want to know if it's a square. So to check if it's a square, we just need to check if its height is equal to its width, right? And so with this property, we don't need to store anything, right? So it doesn't have a backend field. We only need to compute it every time, just check. And so with this, you could do something like this. Okay, so we could define, let's say, our rectangle, and just pass, let's say 100, 100, and then we could just say is square, right? And this will just call this accessor and give us whether it's a square or not. So this one is a square, true, and if we do, let's say this, just say false. Yep, okay. So yeah, so this one, computed property, it doesn't have any backend field. Every time we call the accessor, this gets called. Another thing is, so we saw custom getters, let's see custom setters. So for a custom setter, the syntax is just you say set, and the parameter is the value that we want to set. And then we can, for example, here, we can set the backend field, right? So with name here, field, we can reference it with field identifier, and we can just set it to the lowercase. So what we're doing here is we want, regardless of the parameter passed to name, what will really be set is the name in lowercase. So to test this out, let's test this out. So let's go here, and let's have person3, and let's do p3 dot name is equal to, let's give it something that is uppercase, right? So let's give it John. So this set here with equal, we'll call this set function, and if we print it, it should give us the name in lowercase, right? Because we convert it. So p3 dot name. All right. Okay. So if I run this again. Okay, so you can see you got it in lowercase. Okay, so this is just another example of a custom getter with a computed property. So we saw here an example where it's automatically computed for where the rectangle is a square. A similar thing we can do for an address, right? So if we take this up here. So to get the full address, we can, instead of like storing it in memory, we can just compute it every time. It's just a combination of the other properties. So it's name, street, and city. And this one doesn't have a backend field, right? Okay, so here we have an example, another like more a bigger example. So I have just a class dog, and you can see here I have a val is nice, which is just a Boolean property here. And this with val, since it's this is immutable, right? So we would have, if I do this, it doesn't work, right? I would have to provide it either in the constructor or pass an initializer here, right? And this here would call set value, the default set value that Kotlin generates. But since it's immutable, if I try to define a setter for it, let's say something like field equal to, maybe just do the reverse or something like that. So it won't work, right? Because a val property cannot have a setter, because if we define a setter for it, that means you will be able to set some value to it and change its value, but that shouldn't be allowed since this is immutable, right? And so Kotlin doesn't let us define this define a setter for it. Now a var must have an initial value, right? So let's say I do it like this. I don't define initial value. You can see the property must be initialized, right? Because if we reference it before set is called, and it doesn't have a value, then that won't work, right? But for a var, since it's mutable, right, it can be modified. We can define a setter for it. So here we have a setter, custom setter here. We just make sure that the value is positive and only set it if it's positive. Otherwise, we leave the default value, right? Okay, this is another example of a computed property that has no backend field and cannot have an initial value. So for computed properties as well, we can't have an initial field. So if I try to do 0 here, you can see initializer is not allowed here because this property has no backend field, right? It has no backend field that can be stored in, that can be used to store the value in memory. It's computed every time we call get, we compute it. And so yeah, here it has a custom getter where it just takes the age value and multiplies it by 7, and has a custom setter where it just takes the age. When we set the age in DAG years, we want to convert it to the real age, and so we just divide it by 7 here. Okay, so that covers properties, custom getters, and custom setters. One other thing to note is that if you want to use something else that is not like the implicit backing with this field identifier, you can actually have your own backing property instead of using the backing field. So to do that, let's say here I have a table example and I have a table property here. I want to have my own backing property for it. So I have my own table here that maps from string to int that is nullable and gets initialized to null. So this is the backing property for this property for me. And so we define a custom getter here, and if the backing property value, so I'm not using field here because, right, I'm using our own backing property here. And so if it's null, we initialize it. And if it's already initialized, we don't do anything, and we return it. If it's not null, if it's null, we throw an error that another thread may have modified it because we always guarantee that it's set if it's null here. So if it's here, so if it's null at this point, that means something else happened here before calling return that made it null, right? And so this is an example of using your own backend property for another property, right? Yeah, so that's pretty much it, I think, for properties. The main thing to understand here is the concept of backend field and the concept of properties in Kotlin, and that you can also create your own custom getters and setters. Yeah, so that's it pretty much. Thanks for watching and see you on the next one. Bye.